SpaceX's Starship Flight 9 claims to solve the feed line resonance that doomed its predecessor, Starship Flight 8, and are reinforced methane ducts and updated TPS tiles enough to avert another metal shower inferno. Now, will these engineering upgrades finally achieve orbit, or will a Raptor reignition expose an even deeper design flaw of Starship? SpaceX has not announced a firm date for Starship's Flight 9, but indications point to a late April or early May 2025 target. And after the Flight 8 test on March 6, 2025 ended prematurely, Elon Musk called it a minor setback and stated the next ship will be ready in 4 to 6 weeks. Now, this timeline would put Flight 9 no earlier than roughly April 20th through May 4th of 2025, assuming issues are resolved quickly. Now, the launch window and exact time remain to be determined, pending technical readiness and regulatory approval, of course. And as with previous Starship tests, the launch site will be SpaceX's Starbase facility in Boca Chica, Texas, where the Starship Super Heavy stack is integrated on the orbital launch pad. Now, SpaceX will need a green light from the FAA before launch, and the FAA is requiring a mishap investigation into the Flight 8 failure, but it did allow Flight 8 to proceed even while the Flight 7 investigation was still open. That's after reviewing SpaceX's initial fixes. And barring any regulatory holdups, SpaceX appears eager to attempt Flight 9 as soon as the vehicle and licenses are ready. Now, we all again speculate about Elon Musk targeting 420 or 6/9 as launch dates, but officially the schedule will depend on when engineering and FAA constraints are resolved. The next test will use a new Starship prototype, Ship 35, paired with Booster 16. Now, both Ship 35 and B-16 have already undergone cryogenic proof tests at SpaceX's Massey test site in Texas, indicating they're being prepped for launch. Now, Ship 35 is a Block 2 Starship, part of an upgraded series that debuted on Flight 7. And Block 2 vehicles feature numerous structural, avionics, and system improvements over earlier prototypes. For example, they're lighter and designed for higher performance and eventual reusability. SpaceX modified the Methalox, the methane and oxygen feed system on Block 2 ships, routing methane to the Starship's 3 vacuum Raptors via 3 long, thinner feed lines instead of a single main feed. This change was intended to improve propellant flow, but it may have inadvertently introduced a new issue. Now, both Block 2 ships flown so far, Ship 33 on Flight 7 and Ship 34 on Flight 8, were lost during their upper stage burn. So SpaceX has been analyzing what went wrong. Flight 7 back in January 16th of 2025 saw a leak or a harmonic resonance in the ship that caused engines to shut down, while Flight 8, which happened in March 6th of 2025, suffered an apparent Raptor vacuum engine explosion. That's about 8 minutes into flight, which took out all 3 of the ship's main engines and sent it into an uncontrollable tumble. Investigations suggest that the methane propellant feed lines might be vibrating at a damaging frequency as the fuel tank empties, leading to cracks or leaks that cause engine fires. In Flight 8, cameras captured a large methane leak and a fire in Ship 34's engine bay moments before the vehicle was destroyed. And in short, the Block 2 design changes, while boosting performance, seem to have introduced a fuel plumbing issue that must be fixed to prevent another mid-air failure. Hey, real quick, I want to make a deal with you. I would love you to hit the subscribe button and the like button. And this is why. I continue to make Starship content for you. It's free, takes a second. Not only will you get my content, but YouTube will see that you've interacted with Starship content, and they're going to start promoting other Starship content from other creators, not just me, to you in your feed. And my promise to you is that I'll continue making content that you love. Starship content, SpaceX content, space exploration content, futurism content, all of that just for you. So please take a second and hit the like and the subscribe button. Now let's get back to some more Starship content. SpaceX is implementing mitigations for this feed line vibration leak problem ahead of Flight 9. And Musk characterized the issue as a minor one that can be solved relatively quickly and engineers are likely exploring solutions such as strengthening or better supporting the methane downcomer tubes, adding vibration dampers, or also adjusting engine start procedures. And how extensive the fix will be is still unknown. If it's a simple tweak, SpaceX can just retrofit Ship 35 and 36, which is almost nearly complete with the solution. Now, if a major redesign is required, however, those vehicles might even be bypassed or scrapped in favor of redesigned Ship 37, which would imply a longer delay. But as of now, Ship 35 has passed 3 cryo-proof tests and returned to the production site for possible modifications. Now, teams worked on Ship 36's assembly immediately after Flight 8, indicating SpaceX is pressing forward on multiple fronts. Now, aside from the propellant feed fix, Flight 9 Starship will likely incorporate incremental improvements learned from prior flights. And for instance, Ship 35 is reported to have reinforced catch pins or attachment points on its structure. These are fixtures that would eventually allow a Starship to be caught by the launch tower's arms on descent, similar to how the Super Heavy boosters are caught, rather than just belly flopping into the ocean. SpaceX has already successfully caught multiple boosters with the Mechazilla tower arms, most recently Booster 15 on Flight 8, and even adjusted the catch technique to handle kind of off-center landings. And the tower arms and chopsticks were fine-tuned during Flight 8's booster catch, demonstrating they can move to recenter a slightly misaligned booster and dampen any post-catch swaying. And while Starship catches are not expected on Flight 9, SpaceX will want at least one Starship to survive re-entry intact before attempting to grab one out of the sky. The presence of catch hardware on Ship 35 shows SpaceX is looking ahead to future recovery attempts. Other minor changes being tested on recent ships include adjustments to the heat shield, such as using fewer tiles in certain areas, experimenting with actively cooled tiles, and trying an ablative coating in some spots. Now, that's to improve durability and to reduce weight of the ship, and in some, Flight 9's vehicles should be the most advanced Starship configuration yet, incorporating fixes from the last 2 failures and geared toward achieving a fully successful mission. Flight 9's timing is directly tied to the resolution of the issues and the completion of the required safety reviews. And after Flight 8's anomaly, the FAA opened a new mishap investigation, which must be at least preliminary addressed before another launch. That's a normal step, though. The FAA had also kept the Flight 7 investigation open, but still granted an updated license for Flight 8 once SpaceX provided initial data and mitigations. For Flight 9, SpaceX will similarly need to demonstrate that the causes of the previous failures are understood and corrected. The company's aggressive 4 to 6 week turnaround goal suggests they believe only modest tweaks are needed. But if the fix takes longer than expected, like a significant time, like a new redesign, Flight 9 could slip beyond May 2025. The gap between Flight 7 and Flight 8 was about 49 days. A similar or slightly longer interval after the March 6th flight puts a tentative launch in the late April to mid-May timeframe. Internally, though, SpaceX is continuing to prep hardware, testing Ship 35, B-16, repairs, improvements to ground systems, etc. So they aren't idle while analysis is underway. They're still building that thing. It's worth noting that earlier targets have already been pushed. Prior to the recent failures, Elon had signaled a rapid flight cadence for Starship in 2025, aiming for a possibility of launch every month or 2. Kathy Leaders from Starbase said that in 2024, the company hoped to conduct 25 Starship launches in 2025. This is a huge goal that would require quick turnarounds for the team. Now, the dual failures of 33 and 34 ships have forced a bit more caution, though. They have to work on these things. Flight 8 was originally rumored to fly in February, but ended up launching in March after additional checks and a brief weather delay. Now, with 2 back-to-back ship losses, SpaceX appears willing to take a few extra weeks if needed to implement the fixes. No official delay of Flight 9 has been announced, since the exact date isn't known yet, but effectively, the schedule has slid from the ultra-optimistic scenario. Now, the expected rescheduling will become clearer once the FAA concurs that the new design or procedure is safe. If the fixes work and Flight 9 succeeds, SpaceX could quickly ramp up the pace afterwards. But until then, the schedule remains no earlier than April of 2025, and also subject to change. Now, the overall mission plan for Starship Flight 9 will be similar to Flight 7 and 8, aiming to test the full stack's performance and hopefully achieve the first, mostly successful end-to-end flight of this Starship system. Super Heavy booster. As before, the Super Heavy first stage, Booster 16, will ignite its 33 Raptors and propel the Starship to the edge of space. And about 2.5 minutes after liftoff, the stages will separate. The booster will then execute a flip maneuver and attempt to fly back to Starbase for recovery. SpaceX will again use the Mechazilla tower arms to catch the returning booster out of the air, as was done in Flights 5, 7, and 8. This has become a routine objective for SpaceX. Flight 8's booster, for instance, had a picture-perfect ascent and was successfully caught despite a couple of engine relay hiccups. We can expect Flight 9's booster to perform a similar boost back and landing profile, demonstrating any improvements in reliability and precision. And a successful booster catch on Flight 9 would mark the 4th consecutive recovered Super Heavy, firmly proving that aspect of the system. Meanwhile, Ship 35 will continue on an orbital velocity trajectory once separated. The exact flight profile is still being finalized and may depend on how confident SpaceX is after implementing all of these fixes. But the stated goal is to push the Starship further toward orbit and safely attempt re-entry. On Flight 7 and 8, the plan was to follow a long ballistic arc nearly around the globe. After stage separation, the Starship would ignite its 6 engines, 3 sea level, 3 vacuum, to accelerate to near orbital speeds, then coast and eventually perform a controlled re-entry and a splashdown. In both cases, the target was a splashdown in the ocean roughly 1 hour after launch. Flight 7 targeted the Indian Ocean. Flight 9 will likely attempt a similar path, effectively an almost orbital test, where the ship gains enough velocity to re-enter around the other side of Earth, but not to remain in orbit. If all systems are functioning perfectly, SpaceX might even try to achieve a minimal low Earth orbit on Flight 9, since Ship 35 is a full orbital capable vehicle. However, the safer plan is to retain a slight velocity shortfall so that the ship re-enters on its own pass, ensuring it comes down in a known remote area even if communications are lost. SpaceX has not confirmed the exact landing zone yet publicly. Previously, trajectories hinted at a re-entry near Hawaii or in the Indian Ocean, but it could be adjusted. The primary objective is to get the Starship stage through atmospheric re-entry intact, demonstrating that the vehicle can survive the fiery return from orbital speeds. Both recent flights failed before this phase, so simply having Ship 35 still functional at re-entry interface would be a major milestone. And in addition to the core flight goals, stage separation, engine restarts, thermal protection during re-entry, Flight 9 is expected to carry and deploy some test payloads. Now, like its predecessors, Ship 35 will likely be loaded with a batch of Starlink satellite simulators. They're mass dummies representing Starlink version 2 minis mounted on a dispenser in its payload bay. Flight 7 was set to carry 10 dummy Starlinks, about 20 tons total, and test the deployment mechanism in space. And Flight 8 carried 4 of these simulators, possibly to reduced weight during the troubleshooting phase. Flight 9 will probably include a deployment demo as well. And if the vehicle stays stable after main engine cutoff, engineers would try ejecting the dummy satellites to validate the release system and observe how the Starship handles shifting its mass and microgravity. Any successful deployed test payload would simply fall into the ocean later, as they're non-functional, but proving out the deployment process is key for future missions where Starship will launch actual Starlink satellites or other cargo. And additionally, SpaceX will be gathering data on Starship's aerodynamics and heat shield performance. The profile is designed to stress the ship's flaps and thermal protection by coming in steeply, which helps evaluate the effect of tile loss or damage and any changes made to the heat shield design. And in Flight 8, for example, one of the forward flaps was found severely damaged post-re-entry. For Flight 9, engineers will watch how Ship 35's revised heat shield layout holds up. The hope is to see the ship maintain control through re-entry, perform its landing flip maneuver, and execute a final descent burn, rather than coming back to land on the pad, which is too risky at this stage. The plan is to have the Starship aim for a soft landing in water, essentially a controlled belly flop into the ocean. This was successfully done on Flight 5 back in 2024, which was Ship 30, which gently splashed down in the Indian Ocean after reentry. Ship 30 did not survive long after splashdown. It exploded a few seconds after hitting the water, but it proved a Starship could reenter and attempt a landing burn accurately. And Flight 9 will try to repeat that feat with the more advanced Ship 35. And a successful outcome would be defined as the boosters recovered, the Starship returns, and it also reaches space, and it returns to the atmosphere on target, and as much data as possible is collected up to the moment of splashdown. Now, even if the Starship vehicle is not recovered intact, performing all these steps would be a huge step forward for SpaceX. Now, looking further into the future, though, SpaceX's end goal is to make Starship fully reusable, with both stages being caught by the ground towers. Flight 9 moves closer to that by hopefully validating the Starship's durability and controllability. If all goes well, Elon Musk has indicated SpaceX could attempt a Starship catch with a tower within a few months thereafter, possibly as soon as Flight 10 or 11. But for now, Flight 9's mission is a critical demonstration. It'll show whether the design tweaks have solved the issues that caused the last two failures. And the objectives are clear: prove the fixes, reach or almost reach orbit, deploy test payloads, and bring the ship back through re-entry successfully. Achieving these will pave the way for future flights, higher payload missions, and eventually orbital refueling and moon landings as planned under NASA's Artemis program. Let me know in the comments down below. And while you're down there, hit the like button. And also, if you like Starship content, hit the subscribe button, as you know, YouTube likes that kind of stuff. And they're going to show you more Starship content in the future if you do all of those three things, not just from me, but from other creators as well. So let me know what you think in the comments down below. All right, that's it for today. Take care of yourselves and each other, and I'll see you in the next one.